Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this question. Problem number 73, it is set matrix zeros. Yeah, so the problem statement is kind of a one-liner, but yeah, like after the approaches that we will going to be discuss after that, you will be going to fond of loving this problem. Yeah. So on this problem statement, they have given an m cross n integer matrix, right? If an element is 0, set its entire row and columns to zeros. You can set its entire row and columns to be 0. And you must do it in place. So in place basically means you are not allowed to create any extra memory. Not basically allocate extra memory. Right? So I think the problem statement is one-liner is very clear, and after this example discuss, you can see that it has a centered 0. So this row is going to be turned entirely 0, and this column is also going to be turned entirely 0, and that is the output. That is the output matrix you have to. You just have to do in place modifications. You don't have to return anything. So the return type is none on the function statement, and do not return anything. Modify the matrix in place instead. Yes. So on this you can see this 0 is turned the entire row to be 0 and the entire column to be 0. This row will be going to turn this entire row to be 0 and this entire column to be 0. Yes, definitely. And so you can see on the resultant matrix, it is of entirely 0 of these rows, this row and these columns, these two columns, right? Yeah guys, so the problem statement is as simple as that. And now on the constant you can see matrix dot length is very small. It's kind of like 200, and your matrix ij is holding value of minus 2 raised to the power 31 to be plus 2 raised to the power 31 minus 1. Yes. So you can solve. There are multiple approaches to solve it, but if you incorporate the follow-ups, then actually the challenge is going to be incorporated. Then only the challenge you are going to start to be going to face. So what actually the brute is coming to our brain. So if we can go to our OneNote, if we are going, go to our OneNote, like let's forget to the space things like we have to do in place. This you can get rid of. So a straightforward on the follow-ups they have given a straightforward solutions using a mn space is probably a bad idea. So the mn space is very clear. Like we can basically when this is a 0, we will going to be like know which particular indexes we have encountered that 0. We have encountered just 0. We will going to store that information. So we are going to store that information, and on next go we are going to mark the entire row and columns of the matrix to be 0. So that is the very extreme route, a very extreme route. I'm not going to discuss that. That is not actually. You just tell on the interview on like speaking loud to basically show your speaking loud principles, but don't actually waste any like a single penny of times on this particular approach. Now on the second approach, a simple improvement uses a big of m plus n space, but still not the best. So this we can discuss. Definitely. So what actually the improvement we can do? We can do. So before of that, like I am just going to give you a gist so that you guys can get it. So there is a if you are thinking a very standard like generally like what people are basically doing. Let's suppose you have zeros here. Then 1, 2, 3, 4 all are like normal numbers only. So if you are thinking to do this kind of things, 1 minute guys. So if you are thinking to do this kind of things, when you encountered a 0, you are going to mark the entire row to be 0, and the entire column to be 0, right? That we actually have to do. But if you are trying to do so in place, it is not going to, it is giving you a wrong answer. Why so? So as you guys know, we will going to iterate like this way. This first, then this, like this way, right? First this row, then second this row, which I am highlighting. So when you encounter a 0 here, you are going to turn this as 0, right? Now, and you are going to turn this as 0 and this as 0, right? If you encountered a 0, so if you are thinking this kind of route for I in range in 1 minute is I am feeling an issue on the pen. It will work. And for j in range m, basically n is going to be work in row wise and j is going to be work in column wise. And you are going to check if matrix of I and j is equals to a 0, which all in the problem statement it is mentioned, it is mentioned on the problem statement, it is mentioned, and I am pretty sure everyone is going to get these submissions and get a wrong answer, so if you are thinking, so n and m is also like very small, right? So we can run a n into m into n into m, or it is not an nm, it is kind of like n plus m. So we can run it. So 200 into 200 into 400. So that is going to give you a within our computation power altogether. So 200 into 200 into 400. So on, you are not going to get an TLE, but you are going to get a wrong answer for sure, right? So if you are thinking within this, you are going to run a for k in range n, and you are going to do matrix of what is my row is going to be changed by k, and the entire row that we have targeted, the entire row. So for k in range n, so the every rows. So we are going to iterate for every rows, and column is going to be constant. So we are going to mark it 0. So that means so this one actually. So this our k is going to be iterated to row wise, and we are putting everyone's to be 0 to the entire column by going to every row, and we are going to write another ones again for k in, you can write in range of m, and you are going to do matrix of why I am giving this which is going to give you a wrong answer. Why I am writing these things? Because I'm 100% sure, like more than 60% students that you are watching, you are going to submit these submissions very first go, and after maybe a guidance or maybe a provided example test case, if you run on that test case, you will going to get a wrong answer. So I am on very first go, I am highlighting why this is not going to be happening. So, and here my I factor is going to be constant, and this we are putting to be 0. So that means this entire row we are marking everyone's to be 0. So what actually the problems we have done with this? So exactly this is they are looking for. So after this, my matrix is converted to for a single cell operations. My matrix is going to be converted to, and else I think as it is, whatever the value, 4 5 6 whatever 4 5 6 7, whatever the values it's at, I am not going to be bothered that all are the same values, so now you are going to be now for this, you are also going to convert everyone's to be 0 and this entire columns to be 0, right? And again similarly for this index also, you are again going to be mark this entire row to be 0 and entire column to be 0, and like this way after the first row execution only, your matrix is going to be converted to be all 0, which is wrong answer, which is definitely a wrong answer. What is the expectation? Only this row and this column should be turned to be 0, but with this particular algo, it's converted to whole matrix. With this particular algo is going to convert the entire matrix to be 0. So this is not going to be work for sure. It is going to give you a wrong answer for sure. So what actually our algo should be look like? So we should be some kind of like lazy propagations we have to do. So on very first go, on very first iterations, we don't have to mark them all together to be 0. On very first go, we just identify which of the rows. If a particular row is holding at least a single 0, then we know this row is going to be turned entirely off. This row is going to be turned entirely off by 0. And if a particular column is holding a single 0, that particular column is also going to be turned to be entirely off. So that's exactly the better version. So where they have basically giving us the hints, you can use a big of n plus m space. So we are basically have, let's suppose, a set of rows which is nothing but an empty set, and set of columns which is basically we are initialize can be an empty set. So this should hold the rows, the index of rows where 0 present, and it is holding index of columns where 0 present. So for our example test case, our row set should hold a single 0, and our column set should hold a single 0. So now we can iterate on these particular things. Now we can write for I for maybe a particular index or row in row sets that we have built. So what we have to do? So for this row, I have to turn all the columns to be 0. For row in row sets, I have to turn all the rows to be 0. All the rows to be 0. So how I can so for this particular row should turns entirely 0. So I have some call factor that is for column in range. Tell me guys, for column in range n, and you can set matrix of this particular row which we need to turn off, we can do for this particular row, set the columns, all the columns, so that this row can be exactly turned off. We can set to be 0. So it's turned off. Similar things you can do for that is row set, and you can do similar things you can do for call set. I am not going to write it. So in that case, your time complexity is definitely is going to be the first row set and column set build is going to be a take of big of n plus big of nm, big of n cross m for sure, plus there are certain factors, and this particular things, this is going to be a take big of nm, and we have another for call set. So we have kind of big of nm for one plus big of nm for call set. First one is row set, this one is call set. So final time complexity is kind of big of 3 nm. So that is the time complexity for the better solutions or the spaced consumed solutions. I have to say the space consumed solutions. But here we are using space of big of n plus m, big of n plus m. Yes, agree guys? Yes. So that is definitely an approach. That is definitely a good approach. So that is, I can mark this and as approach 1. But what they are basically looking for, what actually Leetcode is looking for, so that is different on your interviewer perspective. Maybe some interviewer basically looking how optimized time you can achieve for this particular problem. So the solutions that we just saw, that is the most optimal time optimized solutions. No further solution can be optimized more than that. So that is kind of big of n cross n solutions. 3 nm, so 3 factors we can negate out, and that is big of nm solutions. Only big of nm solutions, and space we are consuming big of this n plus m. So this is depends on your interviewer perspective. So tell this multiple approach guys. So we have this thing. So you can tell interviewer that is the most optimized time we can achieve, but we are going to hit on space. We are consuming some space. Maybe interviewer 70 to 80% interviewer are happy with that. They will provide you a green flag. But if the interviewer is looking for this, what actually the Leetcode is looking for, then it is going to, we have to switch our approach. So they are looking for constant space. We can't use this particular space also. So this also we can't use. So what actually we are basically doing here? So I am just giving you, I'm just stating you that if my matrix now actually your logical thinking skills will be solid on this particular approach 2. So now we are on approach 2. So that is actually the most intuitive and most difficult, I have to say. So this is actually the challenge. So now I know if I encountered a 0 here, I can turn the entire row to be 0. That I am allowed to do. But not also, right? Not also. Shouvik, you can do the entire row transformations because we know our iterations is going to be happen like this. So that is the iterations we have to do. So on back I can definitely turn everyone's to be 0 where I have encountered. On the back of that particular row I can turn, but on forward I can't. On forward I can't because if I am going to turn this also to be 0, so when I am going to land on this particular index, it also turned everyone's on the columns also to be 0, which is wrong. So this one is wrong. So that's the problems we are facing. We have already discussed on the first approach. So that's the reasons I am giving you the first approach, which is altogether giving not first approach, the first wrong answer kind of things, because the most optimized space or the most optimized space or what actually the Leetcode or the interviewer are looking for, what the most difficult part of this difficult approach for this particular problems is actually decides to your wrong answer submissions. So that's the reasons I give you the intuitions of how you are going to get a wrong answer. So this we can't do. So this forward 0 propagations, if we encounter a 0, we can't do forward 0 iterations, and similarly we can't do down also 0 propagations. On up we can do. On up, because this up and this left are belonging to my visited part, because when I am at this particular index which I am highlighting repeatedly, this side and this side has visited, so I can turn up and left entirely to be 0 for that particular row and for that particular column. But this transition and this transition I am not allowed to do. So then how I can mark them, how I can basically take a kind of, what can I say, a kind of like directions or a kind of pointers which basically state me these columns, no, this columns is actually this particular columns is actually turned off. So I actually definitely need to do this particular columns to be entirely zero, but not on this time, no. When I am at this particular index, on that particular times I can't do the entire columns to be zero. Then this zero is going to make this also to be zero. Similarly, this also makes this to be entirely to be zero, which is wrong. So, but I need a pointers or I need a indications that this particular column has turned off. But we can't also store that column number, because on approach 1 we have stored the column number which is going to be turned off, and on next iterations we have basically turned them off. So okay. So we have issue, because if I am going to in place turned off, that is going to give you a wrong answer, and if I am going to store to them in a variables, that is going to consume big of n plus m space. So what actually I have the options. Now actually you will face the challenge why approach 1 and the wrong answer is linked together to derive actually the approach 2. So first one, can't put 0 directly, that is going to give us wrong answer. This is going to give you wrong answer. Not store row or call, that is going to space complexity is going to become big of n plus m. So we can't introduce any hit. So what actually we can do now? What are the options in our hand? So I will definitely suggest you take a pause here and think on your own by at least half an hour. After that you should come to this video. So now I am going to express what actually is going to fit here. So the things which is going to fit here, rather than marking to be zero in place, So the problems, I know I have definitely put this entire row to be zero and entire columns also to be zero. This entire row to be zero and this entire column to be zero, but I can't do in place. So rather than if I am going to put some different kind of indications. So when I am going to iterate on the next times, because where the next times principles is coming, because from our approach 1, because on approach 1 we are iterating to our row set and we are iterating to our call set, right? And we are setting on that times it's to be zero. We are setting it on that time to be zero, but we can't store. So rather than storing to them in a variables, can we store them in the matrix itself? Can I store them in the matrix itself? Yes. So I have to put which the entire row and the entire columns, where we have at least a zero occurrence, where we have at least a zero occurred to be some different value, so that I after that when I am going to iterate to this matrix again, where this actually outlier value is lying, I know this gone, this row or call, we just have to replace the outlier value to be zero. We have to just put the outlier value to be zero, but we can't directly put the zero. We can't directly put then on the very this zigzag traversals, this zigzag traversal, it is marking the entire matrix to be zero, which is giving us the wrong answer. So what actually the smartness we can introduce here, rather than if we have encountered a zero here, rather than putting zero to the row or column, I can put a different outlier value, which is not altogether to our present to the given matrix, So I know it's holding integer values, it's holding the given matrix holding integer values, so I can put a character. Yes, it is an outlier. I just have to identify, because on the second iterations I just have to know this particular row or the columns is actually gone. How I can know? I don't have storage. On approach 1 I have storage rows and columns, but on approach 2 I am just on the in place. I am putting an outlier which is doing the indications for us. On approach 1 the indications is by the row set and the call set, but on approach 2 we have in place outliers which is basically doing the indications for us, So I can put the outliers value to this particular matrix. So I can put some outliers values to this particular matrix. Yes. Now I have set my outliers to the entire row and the entire call. Yes. Now and others maybe holding x, y, z, whatever the values a, maybe some not x, y, z, 1 make it to be numeric only, 2, 3, 4, right? So now my matrix is going to become, after this outlier put a 2, 3, 4, 5, whatever it is. So now when we are going to iterate on this particular matrix, which we are doing exactly similar on approach 1 also, when we found an outliers, we know our outliers is a. We know our outlier is A. So we are just replace our outliers. We are just replace our outliers. If we encounter an outliers only, then we are replacing that outliers index to be 0. Yes. Then we are on next iterations, we are replace them to be 0, 0, 0, 0. Yes, yes, we can definitely do this. We can definitely do this, and we are doing everything to be in place. But there is a small catch. There is a small catch with this approach. So that is let's suppose if that is the given matrix, and let's suppose we have a 0 here, and let's suppose we have a 0 here. So when we encounter the first 0, we are doing zigzag. So when we encounter a 0 here, we put the entire row and columns to be outliers. So my matrix becomes A, right? My matrix becomes this, and others I don't care. So when we are reached to this particular index, we have lost these zeros. Right? We have lost these zeros because for these zeros, for this 0 can make this entire row turn to be 0. But as we lost these zeros, as this is holding an outliers, which is not 0, because on zeros only we are marking the entire row with outliers and the entire columns to be outliers, which is already set. But this row setting we have missed. The row setting we have missed because that is not a 0 altogether. It becomes an outliers by this operation. So there is a small things we just need to take care. When we are putting the outliers to the row and columns, so when we are putting the outliers to be row and columns, just check if it is, check if not equals to 0. If not equals to 0, then update it with your outliers. But if it is equals to 0, then keep it 0. Because after this zigzag traversals, when we reach here, we are still getting zeros. We are still getting it as 0. So we are marking this entire row to be A, and entire columns is already A. And now we can do our next go. Replace all the outliers to be 0. It will be 1. So that is the extra things you have to be taking care. If it is 0, let's just skip. If it is 0, then let's not do outliers override. On else case, you can do outliers override. Yes, so exactly that things I have explained. Now we can go to our OneNote explanation. So I have created an outliers named as maxi to be 0. To be A, the characters are our characters. That is not going to be present to be our matrix ij, because our matrix ij integers only. So I have created a outliers to be a maxi named as A. Now we are doing standard things that I have just explained. N and M is the number of rows, M is number of columns. For I in range M, OK equals to false. For J in range M, I will explain what this OK things we are going to do. For J in range M, if matrix of ij is equals to 0, then on that case I am marking this OK to be true. And I am marking the entire. I am marking this entire what? Entire somethings, no? Entire what? Entire K. For K in K is going to be changed. So we are marking this entire columns to be outliers. I am filling the entire columns to be outliers only. Yes, I can do. Yes, I can do this. Yes, I can mark the entire columns to be outliers only. And if my OK is true, so that means for this particular row, we have encountered an outliers. So J, this OK is basically stating the row. We are going to traverse row by row, right? We are going to traverse row by row. So for that particular row, we have encountered an outliers. We have encountered a 0. So let's mark the entire row with the outliers. Let's mark the entire row to be outliers. But that is not needed, no? Because on next go, we are basically for this particular row should be pre-processed. So there no need to mark the entire row to be outliers. We can mark this entire row to be 0 directly. But yeah, you can mark this entire row to be outliers also, and next go it is going to be updated. That is also fine. Anything's fine because this particular row is already processed, no? So we can mark this entire row to be 0 or either outliers. Anything fine. But we definitely have to do either of them. So after this entire job has done, we know our matrix is holding some of the cells as an outliers. So we just have to replace the outlier cells to be 0 only. So I am just taking, if my matrix of ij is holding a some maxi that is an outliers, I am replacing this to be 0. Here the point of notice that I am only going to update in the columns when I'm going to be iterate. I am only going to be update a particular cell with the outliers. Only this particular cells is holding non-zero values because the last explanations we definitely have to take the zeros to be intact in the downward. Otherwise we have missed a particular 0 as an outliers and it is not going to be 1. It is going to give you a wrong answer for sure. So if it is a 0. If it is a 0, then skip it. And if it is a not 0, replace it with outlier. As simple as that, guys. As simple as that. Yes. So the problem is as simple as that. I'm not going to tell this. I am not going to tell this. The problem is as simple as that, because the most optimized space, like in place submissions, is actually the challenge. Now we can quickly discuss our final most optimized solutions, space optimized solutions. I have to say time and space complexity for this. So the time complexity is definitely kind of big of n cross m, and we are running for k in range n. So it is kind of like, tell me, like cubic. So big of here, what we are doing, n cross m cross n cross m cross again m. Yes, we are doing so. We can't compromise this. Why 2 because okay, there is some issue on my keypad. N cross m, then another n here, n cross m cross n. Now inside that, now for this particular m, we have certain m's also. So for this particular n, we have some n also. So this is 1 for it, and there is plus, there is an m factor also. So that is conditional. That is, we can say, amortized. So let's suppose we are getting this okay to be true for every times, for every row, then it is the time complexity we are going to reach for sure. Yes. And this plus a big of n cross n. The big of n cross m. So it is kind of, you can say, a cubic, because here actually the cubic factors has introduced. Big of m cross n, right? Big of m cross n. So that is the quadratic factors cubic factors has introduced. And the space complexity, it is big of 1 for sure. It is of constant space. We have done everything's in place. Yes. So you can see that we have some hit on the runtime. Our submissions is kind of 30% faster. So it is kind of cubic for sure for today. Why so? So maybe I have reached the analysis limit. Not sure why. Yeah, mostly I guess I have reached the analysis times what they are basically proposing. I can't show this. And then on space complexity, you can see like ours is like 95% faster, and it is bound to be the most. So yeah, I can't show this space also, like, but yeah, it is a constant space. We are not using any extra space altogether, and that is the most optimized versions. You should explicitly tell on approach 1. You remember, right? On approach 1, we have a time gain. Where our approach 1. So we have a time gain that is of 3n cross m, that is of quadratic only, but our approach 2 is cubic. It is of cubic, but on space we have a hit. On approach 1, but on approach 2 we are solving it big of 1. So that's actually the approaches. Like, tell these things in the interview to this much clarity. We have approach 1, we have approach 2, we have approach 3, and that is the pros and cons. Now tell me, interviewer, which approach you are good to go, and I will implement on that approach only. And tell these things, like small things, to the interviewer with extreme clarity. Then there is definitely no chance you are going to get rejected to any interview in the world altogether. And if you guys are able to understand all of our approach that we have discussed, so please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product based company and brushing up their DSS skills, and turn on the notifications, so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow at the end of the video. Bye guys. Bye.